Hi everyone, I hope you all are doing well. So what we are going to discuss today, we are going to discuss about the BGP routing protocol, right? So this is more in about the CCNP and RC, and as we have the official syllabus as well, and you can see we have to discuss about the more about the BGP. So already we have done a lot of discussion about this particular BGP, about the basic configuration. We have done discussion about the how the path manipulation is going to be happen. We have done discussion about the state mechanism, different messages type, what is the key concept of the BGP. So today this topic is basically more aligned with the path manipulation, and it's more about the labs, not about the theoretical concept, because we know that we have the different path manipulation methods, and by using those path manipulation method we can manipulate the path. If you go in the books for the BGP books, so I have the book that is the ebook. Basically it's more about the internet routing architecture, so it's a detailed about the only for the BGP book, right? So this book have the different kind of the concepts, and if I go and talk about the different type of the attribute also, so there is origin, AS path, right, next hop, multi exit, discriminator, local preference, atomic aggregator. These all attributes we have the different like the type of the network layer reachability, NLRI, that we have done discussion. We have the EGP, that is the exterior gateway protocol. We have the route, that is the incomplete. So these are the different route in the BGP, which we also have to be good understanding to understand like what type of origin we have, and which the route I am receiving, that is basically IGP route, EGP route, and incomplete route. How this selection is going to be changed, that also we have to understand. Okay, so I'm not going to discuss this all. I hope there are separate session for this, and if you want to learn, so probably you have to start from the basic of the BGP, and that it is going to give the brief introduction about the different concept of the BGP. Along with that, also you are going to understand about how the BGP is going to be configured in very detail, IBGP, BGP, and everything. So now what we are going to discuss about the exact configuration of the path manipulation. So let me quickly show you about the different path manipulation method we have. So just quick recap, you guys also you have. So let me go a little bit down. Should be there. Just hold on, guys. Let me check. No worry, this book have the detailed BGP path manipulation method as well, but I have to search which chapter it is available. But meanwhile, I'll let you show you different path manipulation method as well, which is available on the internet, so you can go and search it out. So what manipulation we are going to do in the lab? So lab is going to start configuring from the very basics. So if I go in the Google simply and I search about the BGP path attributes, so if you just search about it, so there are a lot of articles available. You just open any of the articles, right, and you are going to find detailed concept about the path manipulations attributes. So you have the attribute like we have the weight, that is a Cisco proprietary, and this significance is going to happen within the local. Just recap, okay. Local preference, so if I want to influence the route which is coming from the neighboring routers, and it is going to influence the route based on the local preference value which is going to be set at there. Origin, what type the origin type, it's again E, I, or incomplete. So E is like the EGP origin, I is equal to IGP origin, incomplete, that is a redistributed route which is coming, that is also going to be help to manipulate the path. So we'll do all type of the manipulation one by one, right? And we'll see how this is going to manipulate the path. Origin type, we understand AS path prepend, how it is going to happen. Origin code, we understand. MAD, multi-exit discrimination, how it is going to happen, or which MAD value is going to come in a picture to install the route. EBGP path versus IBGP path, which is going to be selected. So we also do the manipulation based on that also. Then we have the shortest IGP path to BGP next door. What does mean, right? We also have to understand in the labs. Many people are very confused in the BGP attribute. They talk about the weight, local preference, origin, AS path, origin code, MAD, EBGP versus IGP. They don't understand what does mean shortest IGP path to BGP next hop, oldest path, what does means router ID, and finally the tiebreaker is the neighbor IP address. So one by one, all we have to check and we have to manipulate the path. So I'll do the very scratch level of the configuration in the lab. So this is our labs, you can see here. And by going in this lab, you can see this lab looks very complex. So I don't want to use this lab to be honest, but I thought because everyone have to work in the very complex scenario. So they must understand how the complex networking is going to be happen. Okay. So this topology looks not as straightforward for the beginner who is just starting the BGP neighbor. But what you have to just understand, this is my master topology and this is for the CCIE as well. So if you want to do the practice, a lot of things we can do that. So this is the master BGP lab topology where MPLS is also going to become in a picture. MP-BGP also going to come in a picture. So we are not going to talk about the MPLS and MP-BGP. What I'm going to talk, we just have to use this network, okay, in this entire session. So what is this? Just think about your DC server. This is your DC infra. Just think this is your DC infra. Let me write here, DC infra, and this is your branch location. So if I want to start any communication from the DC infra to branch location, then how the step-by-step communication is going to happen. So in first 15 to 20 minutes, we are going to configure entire step-by-step networking. What we are going to configure in the EBGP or IBGP. So you just have to get refresh like how it is going to happen. I can do before the lecture as well, but I want somebody have the beginning knowledge and want to configure something Ospf and BGP, how redistribution is going to happen, how advertisement is going to happen. So this is going to give the complete overview from the scratch, right? So if you want to build your own topology, you want to build your own network. So I'm not going to just talk about this manipulation. It is also from the basic IP configuration, topology configuration, EBGP, IBGP, network advertisement. This topic also going to be covered from today's sessions. Okay. So let us start from the LAN. So you can see this is my LAN infra, this entire LAN infra. In this my two ISP router, they are connected with this service provider. Okay. So they are service provider and then they are also connected with our local internal network. And we have this finally switch, and behind the switch we have the user. So let's quickly configure this C1 and R10 and C2 and R9 and then switch, then user, then we'll do the remaining configuration. So I'll simply go here and let me see if this C1 and C2, okay, that's open. Okay, so I'll go in the basically switch. Okay, this is the first user switch. So what I have to do that, let me check the host name switch 2 and let's see. So this LAN have the network that is the 192.168 network. So also we have to understand how the entire design is going to be configured. So we just have to run the hsrp as well. So my first hop redundancy is also going to be configured in the switch, and this client have the gateway as the VIP IP address. So first I'll configure these two interface. One is going to .2, one is going to be .3, and .1 is going to be VIP IP for the hsrp. This switch have the simple layer 2 will create one VLAN, that is 192 VLAN. This port is going to part of this VLAN, this port is going to part of this VLAN, this port is this piece user is also going to part of this VLAN. Simply 192 VLAN is going to be created on this switch. These three ports are going to part of this this VLAN 02, 03 and 01. So let me do that and then we'll enable this interface and we'll run the hsrp. Okay, so we are doing from the very scratch, so I hope you guys going to understand. So let me create one of the VLAN, that is the VLAN 192, and I can put the name as a LAN VLAN, or I can just put as a user VLAN. So this is one thing. Okay, now I simply go and interface range, and I put all the interface under the VLAN interface range. Why I'm using the range? Because I want to do in one go all three interface in configuration. So gig 0 and 02 and 03 I need to put in the VLAN 192. So gig 0 by 0, so this is symmetric, and then I'll put the gig 02 to 3. So by using this asymmetric means there are no symmetric way of the all interface name, so you can use this kind of the comma and you can put the interfaces in one go for the one configuration. So switch port mode access VLAN 192. So this is done, and I'll just put the right. So the switch configuration has been done. Now I have to assign the IP to this host, right? So let me assign, this is just the host PC. Simply I go and assign the IP address. So IP 192.168. Let me check the subnet. 10.10 I'll assign. Okay, so I'll assign 10.10/24, and the gateway would be 192.168.10.1. that is a VIP address. Okay, so simply I assign the IP address. This is the V host. So IP, so you can say this PC app, but this IP is not reachable because it's not configured right now. So let me check, this is not configured. So this is done. What next? We just have to move to the C router. This two device configuration has been done. Let's move the LAN configuration, this C1 and C2, and then we'll mix with hsrp and this device having the right configuration. So jumping on the C1 router first. So config T, or I'll go in the enable mode. Config T, host name C01, interface. What is the interface? That is 0 by 2. Okay, so interface gig 0 by 2, and IP address I'll use the 192.168.10.2, 255.255.255.0. Also I have enabled the hsrp. So I have to use the standby version. I can use 2, second version, standby IP. I hope you guys know what is the hsrp. If you don't know, just probably have to learn about it. And standby priority, I want to make this as a primary, right? And standby, sorry, I have to give the group as well. Sorry, I just forgot about it. So let me remove this one. I have to create one group. It is going to take a default group, but I don't want to take the default group. I just want to get the one group. So I'll simply go here, standby. If you just click here, this is the group number. So any number I can just use 1, 2. Okay, and I'll just put the virtual IP address 192.168.10.1. then standby 12 priority. I'll just put this one, standby 12 preemption I want to enable, so I just enable. So done this side configuration. On the this is C2, my bad. Sorry guys. So run interface gig 0 by 1. I really apologize for this mistake. I didn't check it's the R1 or R2. So run interface gig 0 by 1. So what I'll do, okay, so actually what I did, this router is C2, but host name I given the C1, so that also I have to change first. So host name, that is a C02, and do show run interface gig 0 by 2, and I just simply make this interface a default interface. Okay, gig. So I want to remove all the configuration, and I use the same configuration on the interface, that is my interface. Here I'm using 0 by 0, and this was a 0 by 0. So sorry, 0 by 3 here I'm using. I really apologize, guys. So this is the R10 and R9. I just mistaken use this. I am extremely sorry for that. So let me, actually this is a big topology, so sometimes we have the such kind of the confusion. Let me configure this. Actually we have to configure the R9 and R10. Okay, so configure the host name R10 router, right? And this is the R1. So see, this is the R10 which is connected with the switch, R9 connected with the switch. So this is the R10 GE0 by 2. So I have to go in the R10 first because this is the upper router. Let me do this time carefully so I can avoid any mistakes. So simply I use this all configuration, okay, and I'll go in the R10. This also have the 0 by 2 interface, and I simply paste it. So this is done, no shut. Okay, what I have to do in the R9, sorry, R9, this interface is connected to 0 by 3. So let me go first here, config t, hostname R9, right, interface gig, I have 0 by 3. So gig 0 by 3, and I just have to assign the IP address 192.168.10.3 this time, and 255.255.255.0, right, no shut. And here I have to use a standby group same IP, that is the virtual IP address. I have to use 192.168.10.1. okay, standby priority, that is going to default 100 if I'm not going to put anything. So I'm not going to put anything, it is going to by default 100. But if you want to enable the preemption, it can enable that shit. And if you check here, so standby brief, so probably they are showing in the unknown stage because it is going to take some time, and now it is showing the active state because might be there are some communication issue. But let me try to ping from this router to this router IP address. So 0 by 3, let me run this interface 0 by 3, and if I just try to ping 192.168.10.2, that should be reachable because they are in the LAN segment. Now you can see the reachable. So my standby also should be come. So let me show you, standby should be come. So see, now it is okay, active. And what is this? So there is some duplicate IP error. So on the interface, I have made something like wrong on this interface. Let me see. So this is IP address, and what is this? Let me show an interface gig 0 by 3 as well. They are reachable, and 192.168. Okay, let me change the version as well. Interface gig 0 by 3, standby version 3, sorry, version 2. So standby brief, there is a version mismatch. So listen state, speak state. Let me see what is going to be happen. hsrp should be come up. Okay, now you see, so there was a version mismatch, so that's why it was not coming up. So what will happen, it's also good questions, right, in interview point of view. So I configured the version 2 here, but I forgot to configure the version here. So this was like not able to like the compatible with the version 1 and version 2 by default. So you have to make sure either you don't have to do the configuration for the version either side, or you have to use the same version in the both side. So now I have the hsrp configuration, and I can see this router 9 is become that standby active, and 10 is active and 9 is a standby. So this LAN configuration has been done. So if you try to ping from this user PC to this gateway, it is going to happen. Let me show you. So if I go in the user PC and try to ping the gateway 192.168.10.1, it should be reachable. The first packet is ARP resolution, so virtual IP is reachable, gateway is reachable, even 2 and 3 is also going to be reachable. See, this is also reachable. This LAN part is okay. So now the next thing, we have to run the Ibgp between these things. Okay, so this is going to be Ibgp connections. So how Ibgp is going to be configured? I hope if you don't know, let me show you how it is going to be configured. So I'll just make sure you understand step by step Ibgp configuration. So this is Ibgp. I just duplicate it and I'll just make this as Ibgp. So what I have to do, C1, C2, R10 and R9, I'll use this and I have to configure this. So let me go and do this carefully this time to avoid any mistake. So R10 and R9 have the same kind of the configuration. You can see means interface here also same interface. So just let me go with R10 first and I'll just go and configure this interface gig 0x0 and IP address. What IP address I have to use? This time I'll use 30.30.1 here and .2 here I'm using. Again 31.31.1 and .2 here. So I'll just use 30.30.0.0.2 and I'll use this subnet as a /32/30, sorry. So it is going to be 252 no shut. The simple configuration, same configuration. If I want to use, I can use show run interface gig 0x0. I can use the same configuration on the R9 as well. Let me see. So R10 we configure, R9 is 31. So I'll use the R9 now and here I'll go, but this time this is a 31. So I'll change the IP address. Okay. So this is 31. So done. This side configuration also done. Let me write the configuration. Now I have to go the C1. What C1? C1 connected with the R10. So this have the 30 IP address. .1 is going to be configured here. So let me do that. So it is going to be host name and this is C1 and I'll simply use this and I'll just change the IP address, this one. Okay, so this is also done. Do right. So if I just try to ping, this should be pingable. C012 like the router 10. So let me ping 30.00.2. So this is reachable. So I'll go and configure the same concept, the CE2, which is connected with this R9. I'll go here and simply paste the configuration, but I have to change the IP from 31 to 1 and I have to put this interface as a no shut and then I'll just try to do ping and I'll use the 31.00.2. Should be reachable because it's the point-to-point configuration. Let me see. So run interface gig 0x0 and this is the IP address. Let me first check show IP interface brief. This interface is up or no? This interface is up. So let me try to ping 31.0.0.2. Now it's reachable. I don't know why it was not reachable. Might be I make some mistake. So now this point-to-point reachability has been done. Then I have to form the Ibgp. Okay, guys. So here we form the LAN network, learn the hsrp. Now in this sections we have to form the Ibgp. So one Ibgp in these two network, another Ibgp in these two network. Okay. So how this Ibgp is going to form? So there is two scenario. I can use the Ibgp. I can use the Ibgp directly between this interface and this interface, and this is the industry standard solution. And here I can run the entire LAN. I can run the Ospf. So there is a one solution that most industry like that is solution, because you have to run the Ibgp between this C1 and C2 router, but there is a one caveat you can understand: before running the IBGP, you have to make sure this interface is reachable from this interface. Means 30 IP is reachable through the 31 to 30 as well, vice versa. So how this reachability is going to happen? You have to make the uses of IGP protocol, that is the Ospf EIGRP static routing. That's why even you can see in the labs, I'm using the Ospf. So this is the only region. So this is the one way I can do the reachability to make the IBGP. Another way to make the IBGP, I can directly run the IBGP in between these network and these network, and I can run the Ospf between these. This is not recommended. Okay. So what I can do, I'll use the Ospf configuration first to make them, this IP should reachable to this IP via this section. Okay. So let me see how it is going to happen. So what I have to do, I have to enable Ospf between these two interfaces. I have to enable Ospf between these two interfaces via the switch. So just this interface, this, and they just have to use in the area, you can put the area 0. And once I'm able to ping 30 to 31, right now it is not reachable. Let me show you. Then I have to make the IBGP connectivity there. So let me go in this particular C2 router, and I am C2 router, and if I try to ping 30 network, it is not reachable because in the routing table I don't have anything about the 31 network, means 30 network. So let me show you. In the routing table is empty. They don't know even the 192 segments as well. So if I try to ping 192 as well, it is not going to reachable because even we don't know what is the 192 IP address, because the routing table is completely empty. So I have to make sure by running the Ospf, I have to make them convert. Then we do the redistribution as well, and then we'll do the next step. So show IP route, you can see this is the completely empty routing table. Even I go here, show IP routing. So let me show you how this is going to be reachable. This is the first condition. My network where I want to build the IBGP IP, either loopback, physical interface IP, they must be reachable each other, then only I can form the IBGP or even the EBGP. If you want to form, this IP should be pingable. And how it is going to pingable? That is using the Ospf. So I'll just simply enable the Ospf on the interfaces. So I'll go on the C gig 0 by 0 first. Let me go. So I'll go here, interface gig 0 by 0 IP Ospf 10. I'll just use the process I10 area 0. Okay, so this interface, and let me do show run interface quickly configuration. I'll just copy the configuration, show run interface gig 0 by 0. So I'll okay, so let me use the notepad. Just give me 1 second. I'll open one of the notepad as well. Just give me, I'm sharing my screen. Okay, so it's done. So I just want to edit this configuration. So I simply remove this, and I need this 2-line command. So I'll just copy this command, and I'll go C2 as well. I'll just paste it. So config t, this is done. So these two routers have the now it's time to R10 and R9. Once I do the configuration of R10 and R9, they will make the neighborship between these two. So let me go in the R9, and I'll just paste it. Done. R10, the same interface. So I'll just go in the configuration. It's done. So this is done. So you have to wait a couple of seconds. You can see the Ospf neighborship has been up, R9, and this is also going to be up. Show IP Ospf neighbor, show IP Ospf neighbor. So this is, see, it's stuck in 2-way state, but it is going to build quickly. So it will take a little bit time. So there are 7 states of the Ospf. So after some time, it is going to build the session of the neighborship. Okay. So just wait, it is going to be definitely happen. So now these two routers make the Ospf neighborship, this and this. Still no IBGP. Now again we have to make the Ospf neighborship between these two interface via switch, but switch don't have the IP address. This is the broadcast network. So simply I have to go on this interface. I have to enable the Ospf, and here Ospf they will automatically form. There is no configuration required because the layer 2 switch, simply layer 2 switch. So it's just going to act as a transparent. It's process the OSPF packet. Nothing is going to require. So let me configure OSPF on GE02 interface and GE03 interface. Simply I'll go here and change the interface, and I'll just use the same command, and I'll go on this R9 router. See, now this OSPF also came up after some time. So it's a full state. So I'll make the configuration. Okay, let me R9. Okay, R9 have the different interface, I believe. R9 have 0/3, sorry. So this need to be on R10. So R10, let me go in the R10 first, and then we'll change the R9 as well, because there is no configuration, so they are not forming the BGP. And now let me change the interface ID, and simply I'll go in this R9 as well. And after going in the R9, I'll just configure this OSPF. This is also done. Okay, so wait for a while. This also going to form the OSPF neighborship. So once we have the OSPF neighborship now, so this entire network is going to be exchanged. This one OSPF neighborship, this is another OSPF neighborship, and this is going to form the another OSPF neighborship. So by default, they are going to stay in the same area, that is area 0. So this network is going to reach this router. This router is going to advertise this network, and every router now they are going to get the all network reachability. So by default, your routing is fine, and you should be able to reach from 30 to 31 from here to here. This is our end goal. And even from this router you can reach to this network, from this router you can reach to this network, and from this PC also able to reach to this all IP address, because they are going to be full converged network and they are going to belong in the same area. So let me show whether this OSPF is up. So now you can see even the OSPF is going to be built. So you can see now this R9, this router has built the OSPF neighborship with the G0/2 interface, which IP is, you can see 192.168.10.2. So if you go and check the IP of G02, so this is your IP address. Okay, so I hope you understand. Now if I go and check the routing table of the CE2 router, you can see earlier routing table was empty, there was nothing was there, but by doing this OSPF configuration, show IP route, if you see that, you start learning about 30 network. So if I just try to ping now 30 network, 30.0.0.1, you can see you are able to reachable. Similarly, if I go in the C1 router, earlier they don't have the 31 network reachability. You can see this was the routing table, nothing was there. But if I check again, it should have the 31 router reachability as well. So let me show you, this is the IP address, and if I just try to reach 31 as well, so 31.0.0.1, it is also reachable. Even see this 192 is also, it is available. So if I just try to ping, this is also reachable, all IP are reachable. So we have the full converged network, every IP able to ping to another IP address. So now we are good. Now what is the next task? In next task, we have to build the Ibgp between these two router. So what is the thumb rule IPBGP? The IP which you are going to use to build the Ibgp, that must be reachable via any IGP routing protocol, even from the BGP routing protocol. So we make them happen via OSPF, via this way. So the routing is available and IP reachability is there, then I can configure the Ibgp. So what is my AS number? This is my AS number. So let me configure the Ibgp that is going to build in the same autonomous system. So let me configure the Ibgp on the C1. Meanwhile, let me write the all configuration. So probably we can use from here. So C1, I'll go and configure the Ibgp. So how Ibgp is going to configure? So you just have to use the command router BGP. And what is my AS number? My AS number is 64002. So 64002. And what is the neighbor? So from C1 point of view, my neighbor is 31.0.0.1, which is reachable, 31.0.0.1. And remote is, this is the Ibgp. So this is the same remote is 64002. Done. My Ibgp configuration of router 1 is done. So just wait. If I just try to run so IPBGP summary, there is no BGP neighbor because I didn't configure another side. Okay. So see, this is the ideal condition. So it should be come up. So let me go in the CE2 again, and I have to do router BGP 64002. I believe this is same as, let me verify, 64002, and this time neighbor would be, this time I'm CE2 and I'm making with CE, hold on, CE2 I'm 30 IP. Okay, so let me configure the 30 IP address. So I'll go here, neighbor 30.0.0.0.1, remote is 64002. Wait for a while, this BGP is going to be up. Just wait for few seconds. So now you can see this log will say just 2-line commands make the BGP up and working. Let me use a different color. See, so this BGP has been up and working, and this is the Ibgp. How I can identify? Let me run this command, show IP BGP summary, and if you want to check whether this is the eBGP or iBGP, the best way to identify, you can see what is my on AS number and what is my remote AS number. If this is going to be same, okay, this BGP is known as the iBGP. If these two AS number are going to be different, then it is known as the eBGP. So now you can see my on AS number, right, local AS number, and this is my remote AS number, neighbor AS number. So this is the same. So this is the iBGP connection. And you can see we are not learning any prefixes, 0 prefixes. Okay, so till here we have done. What next? Now we have to build the eBGP session. So these all has been done. Still, after doing the eBGP session, we do the path manipulations. So just wait for a while. So now we have to bring the ISP link connectivity from C1 to P, and like we have to connect our server as well. So this part has been done. We are not advertising any route, but we have done the basic routing configuration. Let me do on the C1 this link 1110. We just have to configure by 0x2 interface and this 0x4. So I'll go here. I'm on the C 0x2, and in this I just use the G 0x4 interface. So interface gig G 0x4 IP address. I'll just simply go and use 2.1.0.0.0.1 I'll use, and 2 I'll use here. Okay, 2.1.0.0.0.1 255.255.255.0 no shut. So basic IP, then we'll run the eBGP. Do right. Keep writing configurations. So if you forget, it is not going to loss everything. G0x2 1110 IP address. Okay. So interface G0x2 IP address 1110.0.0.1 no shut. Do right. Okay. This has been also done. What next? I have to go in the PE routers. So let me see, this P1 and P2 is open. So we have P2 and P4. Okay, so these routers already open. So let me go in the P2 first, and we'll run again the BGP. We'll cover the MP BGP in different session where MPLS I'll cover. All right, so I'll go here and simply I'll go on the G0x2 interface gig 0x2 IP address, this time 1110.0.0.2 I'll make no shut. Wait for a while, I'll check the connectivity whether I'm able to ping from C01 router or not. So I use the command do ping from the configuration mode 110.0.0.0.1. If it is reachable, our connectivity is done. So my connectivity is done for CE P2. I'll go and do the same on the P4 as well, and then we'll do the eBGP configuration. So host name P04. I forgot to change the host name on this router. Yeah, it is already there. Okay, and in this scenario I have G0x4 interface. So interface G0x4, it's G0 by 4, IP address 210.0.0.0.255.255.255.252, no shut. Interface, make sure it is going to be no shut condition. And now it is up. So I'll simply just do the basic reachability test whether they are reachable or not. So now it is reachable. So what next? So the next thing, we have to make the Ebgp communication. Means the Ebgp, we have to do the configuration from this CE to P, and this time we have the different AS number. So I'll start with CE1 and I'll make the P2 connectivity Ebgp, and then CE2 and P4. So let's do it the CE1. So I'll go in the CE1. And how I can do the BGP configuration? I have to go in the router BGP 64002. This is my AS number. And what is my neighbor? So neighbor is the same IP address which is configured on the P2, but 2 and remote AS this time is going to be different. This time remote AS 6455. So 6455 remote AS. That's all about the eBGP configuration. 2-line configuration. It's still BGP is not up, because another side configuration is still pending. So if I just show your BGP configuration, what we have done till now. So in this router, we created one IBGP which is up and working, and this is the eBGP. If you just check the status, it is showing to down, because still we have to do the configuration the P2. So P2 again I have to go in the router BGP. This time this having AS number is 6455. Okay. So, and what is my neighbor? So neighbor is my .1 IP address, and remote AS this time is going to be happen 64002. And I'll just come out here and write the configuration. After few seconds, my BGP, eBGP is going to come up. So just wait and see. And now you see the logs. You can see the last line, BGP adjacency like neighbor is up. So if I run the command show IP BGP summary, you can see this BGP has been up, but there is no route. If I check here also, the both BGP is going to be show up and working. Now, okay. So it's time to do the configuration same on the CE2 router. So I'll go here, say router BGP and AS number 64002, and neighbor I have to use this time 210.0.0.0.2, but remote AS is going to be 6455. Okay, do right. My BGP is going to be configured, but the BGP is going to be still down, because another side I have to configure the BGP. So this is down state, and I have to go in the P4 router, and I have to use the similar kind of the configuration that related to the so IP router BGP 6455, and neighbor this time I have to use this neighbor, and remote AS that is 64002, and wait for a while. Again this BGP is going to be come up. So now we have done the eBGP connectivity as well, but still there is no route advertisement is going to be happen between any communication. So still they all are going to be down state. Means there is no route. BGP is up, but you can see this is came up, and if I go in the P2 as well, so IP BGP summary, it is also showing up. So everything is down, everything is up, but there is no route receiving here. Now we have another BGP here. I can run the iBGP with this particular server. This is a Cisco router. So let me just open it, and I'll just do the iBGP configuration with the both router in the cloud. So this is my config hostname. I can put the P, and after putting P as a host name, I'll just configure interface, and this interface is gig 0 by 2 and 3. So let me do that quickly. Interface gig 0 by 2 IP address. I'll simply configure what is IP address. That is my going to be happen. IP is this IP is going to be happen. Just wait for a while. 89.00. I'll use the 1 here, 2 I'll use here. Okay. So 89.0.0.0 1 255 255 255.252 no shut. Okay, so this one interface configuration done. Similarly, I'll use 0 by 3 and I use the 79 IP address. So let me go up arrow, and this time I'll use 79 IP address, 79 and no shut. Similarly, what I will do, I will use this DC network, right? And in this DC network, I'll have to advertise in the BGP. So I have to configure the loopback. So let me configure quickly few loopback. Interface loopback 1, IP address 1.1.1.1, 255, 255, 255, 255. This is one loopback. I'll configure one other, sorry, 2, right? And the IP address, I'll use this 2.2.2.2, right? I'll use the another loopback is a 4. Okay, just wait, let this interface come up, and I'll configure the IP address 4.4.4.4. okay, I'll configure another interface that is a loopback 8, and I'll configure the IP address. This time I'll go and configure the IP address 8.8.8.8. Why I'm doing this all, you understand, wait for a while, because when you want to build your own labs, you should know what is the step-by-step process. Else I can just simply configure by on, I can do everything like just for the manipulation part, but my intention is just show you everything, so at least you do in your system. Now I have to run the Ibgp again here. So these two devices need to run the Ibgp, because this is your data center. Just think about it. Okay, so how the Ibgp is going to run? So just forget about this link. For time being, we are not going to use, or let me for time being delete this link. No use of this link for time being. Okay, so I'm just deleted this link for time being. So simply I run the Ibgp configuration. Let me complete on the P router first. So router BGP 6455, and I have one neighbor is, this is my one neighbor is going to be 72, remote AS, it is going to be 6455, and this is my another neighbor 79. Now we're done with the Ibgp configuration of this P router. This is going to be down because we also have to configure the same configuration on the C router. Okay, so let me show you, show IP BGP summary. This is active down. So let me go C2 and C1 quickly, and C2 and C1, if I just go here and I'll show you, this is the C1 have 0 by 2 interface. No, this is not, sorry, P2 have 0 by 3 interface. P2, let me go P2. So configure interface gig 0 by 2 IP address, and this is going to require IP address is 79. Okay, so 79.0.0, and what we have done the configuration on the P router 2, right? Neighbor is 2, so I'll just use the 255 255.252. okay, no shut, and I'll simply run the Ibgp here. So router BGP, oh, I make the mistake, should be 0 by 3. I use the, okay, so let me correct it. IP address should be, this is the 110. Let me see what was the IP address we configured on this particular interface. It must be available here. Okay, this was IP address. Okay, so we just have to configure this 0 by 3, and I have to use the IP address. This time IP address 79.0.0.0, and this is going to be 255 255 255 252 no shut. Okay, and I have to use the router BGP 6455, and neighbor should be 1, and remote is, it is going to be 6455. Okay, so let me see. Show IP BGP summary. Show IP BGP summary. So you can see 1110 is up. Now you can see this is also up and working. There is no route. There is no route. So we'll see how the route is going to be propagated and how the all ISO is going to be arise. Now it's time to go and do the same configuration in C2 as well. And sorry, not C2, the P4. So let me go and do the similar configuration of the P4. I'll do this time carefully. The lab is a little bit complex, so you have to be extra cautious while doing the configuration, else it is going to be masked. G0/2 this time. So interface big 0/2, IP address, and this time we have to use the IP address is 89. 79.0.0.0.2, 255, 255, 255, 252. I use the no shirt. Okay, this must be came up. Okay, and router BGP 6455. This is last configuration we have done in the BGP, and I'll use this command, and I'll put the remote as a 6455. All right, so we all done in the BGP IGP configuration. It took little time, almost 50 minutes, but it is very important. Now we have to do the path manipulation. You have to understand how the default communication is going to be happen first. So let me show you. So BGP summary. So IP BGP summary. BGP summary. So this is your, like the BGP, there is no route. So the end goal is I want to make sure this PC should reachable to this all network. This is my end goal. This is the first lab, right? The first lab, this LAN should be reachable to DC network. Currently, if you see that there is no reachability, then how it is going to be happen? Let me go in the user. If I just try to go in the user and try to ping 1.1.1, see, this is not reachable, unreachable. If I try to reach 2.2.2.2, it is not reachable. Even I try to make the 3.3, not 4.4 network, not reachable, because they don't know how to reach from LAN to this all network. So what we have to do that, because we are running the BGP, right? So the network already BGP, Ibgp is here, right? Ebgp is here, right? Ebgp is here. Again, we have this Ospf network here, Ospf network here. So first we have to advertise this all network in the Ibgp. It will reach to the P will directly advertise to the Ebgp. So now this route is going to reach in this CE router as a BGP route, basically Ebgp route. Then you want to send in the LAN, so you have to redistribute BGP to Ospf. This is the first process, BGP to Ospf. So this is going to be happen. Now similarly, if I want to make sure this LAN subnet also able to reachable in this particular DC network, so I have to make sure either Ospf need to advertise in the BGP, or because this is available in the routing table, so I just use the network command to advertise this LAN segment to the BGP world. So this is going to available on this P router. It is complex. Okay, let me rephrase and explain you again so you understand. So what we are trying to do, I want this PC should reachable to this. We don't care about this path, it is going to have this path. I don't care, we'll do the manipulation later stage. But first thing, we have to make sure whether they are reachable or not. So how it is going to reachable? Means routing is going to work based on the source and destination. So this P router must be know about this source address, and this source address must be know about the all destination address. But if I check in the P routing table right now, so there is no route available here. So if I check here, show IP route, they don't know about the 192 segment. See, nothing route is available at 192 subnet. Similarly, these are the gateway R10 and R9. They know about this 4 and 1 router. They don't know. Let me check about it, because even they don't have the communication. So show IP route. So now I have to do the advertisement. So let me do on the P router advertisement. Simply I have to, how I can advertise the route in the BGP. So run section BGP. And after going in, I have to go in the configuration and router BGP, and I have to use the 6455. This is my router, and there is 3 ways to advertise route in the BGP. One is via network command that we am going to use. Second one is the redistribution. The third one is the aggregate, like aggregation, by doing the aggregation. So we are going to use this one. Redistribution we will understand later state. Aggregation also, once we do the summarization, we use the aggregation also. Advanced thing we are going to understand. So this is the most way to advertise, but the one condition is there. Any route, if you are going to advertise any subnet in the BGP table, there is a one condition. Any route which you want to advertise from the router, that route must be available in BGP routing table, means not BGP, in routing table. The route must be available in the routing table either via any IGP, any static, or connected, anything. So right now, if I am trying to advertise 1.1.1.1 route, 4.4.4.4 route, 2.2.2 route, 8.8.8.8 route, are they available in the routing table? If they are not going to available in the routing table, I cannot advertise. So see, they are available right, directly connected. So the condition is whether this should be available and directly connected, or via static route, or via any IGP routing protocol. Then only I can advertise the route in the BGP table. If it is not available, I cannot advertise. This is the thumb rule by using the network command. Even you are going to do the redistribution, it is not going to happen. Even you are going to do the aggregation, it is not going to happen. The route must be available in the routing table by any format, either IGP, either static, any connected, then only it is going to be advertised in the BGP. This is the thumb rule. You have to make a special note for it. So let me advertise it. So once I do this advertisement, right now you see here, before I start doing this P router and this P4 router, they are not receiving any route from the P neighbor. So IP BGP summary. Let me run this command. So there is 0 router receiving from this 79 neighbor. But once I advertise, they will start receiving the route. So this is a network command 1.1.1. You have to use the mask 255. This is how you have to give the mask. You have to give the network ID and it's a mask to advertise the network. So one network, this is a loop back. If you have the complete subnet, you have to give the complete subnet as well. We'll show how the complete subnet is going to advertise. 2.2.2, 4.4.4.4. Okay, and this is your done. Right, let me check on the P2. This is the first output before advertisement, and after advertisement, see, they start receiving 4 routes. And even I want to verify whether my routes are getting advertised or not. So show IP BGP neighbor. I can specify any neighbor like 79.0.0.0 and advertised route. So it is showing what all advertised routes I'm doing here. Even for the 89, if I want to do that, I can use this all. Okay, so route is getting advertised, and this P2 and P4 also, if you check this was earlier, it is start receiving this route. So now this route reach from here to here. Will this CE1 and CE2 is going to receive the route? Let's see that. So we don't do anything, but let me check that CE2 and CE1. So which is the upper one? Upper one is CE1. So let me go in the CE1 first. And if I just check it, whether my P router is sending route. So you can see here, this is also start getting the 4 routes, and it is also start getting the 4 route from the LAN network as well. Let me go in the CE1. CE1 have the IBGP. So what is happening now? This route is getting advertised to this one. This one also getting advertised to this one. So this is IBGP. This is also sending this route, and this is also going to send this route because this is the Ibgp. So no need, it's a normal behavior. If you want to stop, you will see that how this filtering is going to happen, but it's a normal, no need to worry about that. So simply the route is getting started, but are this, so there is one rule. Just give me 1 minute, guys. I'm just pausing this video. I have to take one call. Just wait. Just wait. I'll start. So because of that, right, it is not the default method of advertising route is just because you are exchanging the route. Just wait, just give me 1 second more. Sorry guys, so this is a thumb rule, right? Any route it is going to advertise from the network, by default Ibgp is going to send to the Ebgp. Okay, so see, this is the Ibgp. It is by default sending, you don't have to do anything, it's dynamic. So it is sending to the Ebgp, and further Ebgp is sending to its Ibgp. Okay, clear? But Ibgp, let's suppose there is another Ibgp is going to be happen, so it is also going to be shared by this router, but another Ibgp is here, this is not going to share. So we will see how the split horizon rule is going to happen and all things. We are not going to talk this, but this is a default, right? It's a dynamic. So by default, this all router routes we are advertising, they are reaching till here to here without any issue. So now if I go and check the R4, sorry, R10 and R9, will the routes are getting here or not? So let me check here, routing table. So we don't have route for the 4.4, 1.1, 8.1, like 8.8. Why? They are receiving till C1. There is no problem. If I check in the routing table, they are learning because they are the BGP routes. You can see they all are tagged with the BGP route. BGP route by default never ever going to advertise in the Ospf. So you have to do the redistribution from the C1 to the R9 and R10 because we are running the different routing protocol domain here. So how the redistribution is going to happen? So let me show you. So I have to make sure these two routers must be received the route, then only once this PC will try to reach there, it will first reach to the gateway, it will take the routing table, then they will take the further path to reach the destination. Okay, so let me do that. So let me do the redistribution as well. I'll go in the C2 first. How the redistribution is going to happen? So I have to go in the router Ospf 10 redistribute BGP, and I have to give the AS number 64002. This is the AS number. Configure in this C2 router. Okay, so one router has 64002. Okay, so I'll just give this done. Okay, so this configuration is done. Similarly, I'll go in the C2 also, C1 also. I'll run the same command because we also need a redundancy. So router BGP 64002 redistribute. Sorry, I make the wrong statement. I have to go in the Ospf. So router BGP, not BGP, Ospf 10 redistribute. We are redistributing the BGP route 64002. Okay, this done. Write it. So now this is done. So if I just check now, redistribution done. If I want to say the command for the Ospf, you can just see this command as well. Redistribution done. So if I go in the R9 again, and if I check the routing table, see, we start getting all route, DC route means from the E2 because they are the external routes. See, you will start getting these all 4 routes here without any problem. So we are good till here. If I check the R10 as well. So one question for the everyone. If you're watching in the YouTube or somewhere else, one question for the everyone. as we receive this subnet route, okay, listen carefully and pause the video and try to give the answer. As we advertise these all network, and they are now via this part to this part, they are able to reach this router and this router. This PC gateway is here. So the packet is going to be this, look like, let's suppose this is going to a source IP address. This is your destination IP address. This is a 192.168.10.10 and they want to reach 1.1.1. So the first is going to be hit to the gateway. Gateways take the route. Yes, routing table have this 1.1 route. Will they communicate as per the current configuration? If you have listened all the entire lecture till now, just for the question to you, an answer. If you are watching in the YouTube, just put your comments as well. Will they going to reachable? Let me show you the R10 and R9 routing table as well. So you see this route is available, but will it reachable? If not, why it is not going to reachable? So the answer is definitely it is not going to reachable because we don't have the reverse routing. Let's suppose the packet is going to be initiated. This packet is going to arrive in this P2 router. If you want to check, I can just show you the debug capture as well. But there is no reverse route how to reach to this source address because routing also have to check the reverse route as well. So the answer, right, you have to advertise this network also in the BGP so that it is going to reach to the P router. So if I just go in this particular PC, let me just try to ping 4.4. It is not reachable. You can see it's showing a timeout. But if I just go and debug the packets, you will see that debug IP ICMP packets. Debug IP packets. Okay. So let me initiate again the packet. Probably we'll see some debugs result. So it's requesting. Let me go in the P router. See the packet is coming. You can see your packet is coming. Let me stop the debug. So you can see, but we are not getting reply. This packet is coming. If you want to see, this is my source IP address. This is what I was trying to say. This is source IP address and this is a destination IP address. So it is not like your packet is not coming. Your packet is exactly coming from this PC to this PC, but this doesn't know how to reach to destination. Means this packet is going to reverse again. Source is going to be destination and destination is going to become a source. So in debug, you can see that the packet is coming with the source, this IP address, destination, this IP address. But when it is trying to reverse lookup, right, routing lookup for the source and destination, this is getting failed. So see, routed via the RIP. Okay, if you read this, and this is your source, destination, and this is all packet type. So this is unroutable. You can say this is a notation as well because we don't have the routing on the P router. So let me show you, show IP route. So we don't have any route here for the 192 subnet. That's why this packet is not reachable. Clear? So you can see unroutable. Why it is unroutable? Because we don't know this destination address. The routing is trying to reply on this destination. Before it is trying to reach the destination, it must is going to check the destination IP address in the routing table, which is not available right now. All right. So how it is possible? So we have to advertise this 192 segment as well in a BGP so that it is going to reach here as well. So let me advertise in the C router. And what is the condition to route advertisement via network command? The network you are going to advertise in the BGP that must be known via the any IGP, any connected, any your static routing. So this is right now learned by the Ospf. Let me show you. If I go in the R9 and I check the 192, you can see not R9. I have to go in the C router. Sorry, C1. So if I go in the C router and I check the show IP route, you can see this is learning via Ospf. So I can advertise this route in the BGP. Show, hold on. Let me fix this. So I'll go here and I'll just run the show run section BGP. So run section BGP configuration. and I'll use the router BGP, and it is 64002, and I'll use the network. What is network? This is 192. So see how it is going to advertise. Complete network, not a single host. So 196.10.0, and mask you have to put 255.255.255.0 this time. Do right. So this is done. Similarly, you have to advertise for the C2 as well. So I'll go in the C2 as well, and if you run the so run section BGP, config T router BGP 64002, network is going to be 192.168.10.0, mask is 255.255.255.0. right. So this is done. So now if I go and check on this P router should start receiving this route from this C1 and C2. Let me go on the P2 router and check the routing first. So IP BGP summary, you can see they start learning the one route. And if I want to check show IP BGP neighbor, and I just put this neighbor, what route I am receiving, and just put the command routes. So you can see you are learning this route. Similarly in the P4 also you go and check. So my job has been done. So IP BGP summary, and I run the command so IP BGP neighbor 210.0.0.0.1 routes. You see you start receiving, and this is the valid routes. So P4 start receiving. So my P router also start receiving this route. Let me check whether they start receiving or not. So you can see that this route is not installing the routing table. And what could be the reason? Let me check the SWIP BGP summary. I am receiving this route. Okay, I am receiving just one route, and let me check what route I am receiving, but it is not installing the routing table. So this is also a good reason to understand and troubleshoot why it is happening. And this is the reason I want to start from the very scratch. So at least you understand each and everything, what kind of problem is going to happen while the route advertisement method. So IP BGP neighbor, and I'll use this one, and I simply check the routes, what routes I'm receiving. So you can see you receiving the route is 192, clear? But you see here, this route is not a valid route, and this is the reason it is not installing in the routing table. This routing is not in the routing table, so this is not installing. That means this is not valid route, that's why it is not responding in the routing table. Just give me 1 second. Wait guys. Just give me 1 second. All right, so we have to fix it. How it is going to fix? I will share it. All right, so someone texted me. So again, I will just go and I'll check the another neighbor, that is 89. What is happening? So show IP BGP neighbor and routes. So this is also receiving, but not a valid route. You see carefully, these routes are coming, but what are their next hop? So the next hop by default, it is saying as a 210 and 110. See, does this P know about this two next hop? Means this P is receiving the route. It's absolutely learning from the BGP, but the next hop is coming as a this network and this network. These two IP are available in the routing table. So the first condition for any route which is going to install in the routing table, their next hop should be reachable. You also note it down. Next hop should be reachable. You have to take it note down. But right now, if I'm going in the P and try to ping this next hop, is it reachable? Let me see. If these are not going to reachable, it is not going to install in the routing table. See, it is not reachable. It is not reachable. I'll ping the. So by default, there is one concept you have to note it down also. If I just try to ping this also, it is not reachable. So by default, when any eBGP route, by default, again I'm explaining, by default, any eBGP route is going to advertise the iBGP neighbor. Their next hop means the originator of the route, the hop never going to change by default. So it is reaching P2 simply transmitting that the P router, that is a DC router. So that is a default behavior, and you have to change default behavior. You have to use the special command next hop self command in the BGP configuration against these two neighbors to avoid this configuration. Else you have to make them reachable via any IGP, but this is not recommended. Sorry, not IBGP, this is IGP, but this is not recommended. So let me configure the next hop self. So I'll configure on this P2 router any route you are going to advertise in this IBGP neighbor. You just use your own hop IP address instead of the remote one. All right. So let me go and make them happen. So I'll go in the P2 first, and I'll go in the BGP and section BGP, and in this configuration what I'll do, I go here and I use again this neighbor. When you advertise any route for this neighbor, use the command next hop self. Okay, done. And now if you see that, let me go quickly on the BGP again, and if I run the again this command 79 we've done, right? It will change the next hop after a while, or we have to clear the route. Just wait. Let me configure the another one also. So where we done the configuration, P2 I believe we have done, and we have to done the P4 as well. So let me go and do the configuration, then I will do the BGP refresh, and it is going to solve the issue if it is not going to update by default. Neighbor, and this is the neighbor, and use the next hop self command. All right, so this has been done. All right, so now the next hop self command has been done, and let me just check the whether they are refreshing. See, the route has been installed. It's a valid. Earlier it was asterisk. What does it mean asterisk? It's a valid route but not the best route. If you have the valid and best symbol here, then it is only going to be installed in the routing table. So now you see the neighbor which was earlier having the 110 as a next hop, now it's changed to 79. And if you change the like the 89 as well, it is also going to solve the issue. So it is not installing because one best route is installing. So once the 79 is going to down, then it is going to install. But end of the day, the packet has been installed in the BGP routing table. Only one packet is going to be installed. One neighbor is going to install. This is the default method of the selecting the route based on the default attribute. So we'll discuss about how the selection was happen. But your routing has been done. Now if I go in the user 2 and try to reach again, see my end-to-end reachability has been done. So if I just try to trace again 4.4.4, you will see that, let me try here, the trace is also going and my packet has been reached. But which path they have taken? This is the actual engineering going to come in a picture, the path manipulation. The path manipulation comes from here. I can start from the very beginning, to be honest, but I really don't want to do that. You have to understand first topology, then path manipulation is going to help you. But let me explain how it is going to happen. So if right now I didn't do anything, but still my path manipulation has been completed, and you can see my packet is reaching to destination. I'm able to ping. What is the path they are taking? The first hop of this, the PC is reaching to the your which router? This is the 2 is configure the R10, I believe. Let me see. Show IP interface brief. 2 is configured the R10. Let me check show IP interface brief. Yes, dot 2 is configured the R10. So the first hope is your, let me go here again, trace PC. The PC is going to the gateway. Gateway of the PC is a virtual IP. Then it is the R10. Then R10, it is going to 30.1, which is 30.1 IP. There is a C1 IP. See the C1 30.1. Then it is going to C1. C01. Then after it is going to the 110.2, which is the network, and where this is configured. This is the P2 router. Okay. So this is going to the P2 router. Then it is going to finally P router. So this is the path. So we have default attribute here, but my packet is coming from this PC. Let me draw here. The packet is coming from this PC, going to the switch, going to this R10, R10 to C1, C1 to P2, and then it is going to here. So this is a default path taken by the BGP. But what if I want, no, my packet should go via this way. When I want to do this, this is known as the path manipulation. And this is the entire thing we just have to understand. There is a lot of way to do the manipulation, which I explained in the BGP. So I'll just give the brief, like the one of the way. Later we'll do the one by one for the all attributes. Let's do the path manipulation with the help of the local, AS path prepend for time being. Okay. I'll explain every path manipulation, but let's understand first the AS path. What is the AS path prepend mechanism? So AS path, that means the route which have the shorter AS path, they are going to select as the best route in the routing table. What does means? Let's suppose this route is coming. Okay, this route is coming via this way to this router. This is the BGP zone is configured till here. Okay, this route is also coming to this. Okay, they are running the Ibgp. All right. So what is going to happen? Let's say suppose this route coming with the one AS number, means just 6455 here. 6455 here. It is also going to come 6455 here. One AS. So both having the same AS distance, means the same AS like the included in the prefix length. So they are not going to select based on the AS. They will go and select the further attribute. Might be they are going to select to install the route based on the oldest route, router ID and the neighbor ID. But I want forcefully this route which is coming from this P router, they should have the 2 times AS or 3 times AS, and this is the 1 time AS. So this router will take the less preference. This is going to take the higher preference while installing the route. This is the AS path prepend mechanism. So AS path means you are just going to by default any. Let me show you how the AS path. So let's suppose this is the BGP and I am receiving this 1.1 route. Let me see how many AS I am receiving here. So I'll go in the C1. You guys understand, and I'll run the command. There is show IP BGP, and the BGP route is this. See this route having how much AS number? 1 time AS number. Okay, and same route I am going to check in the C2 router. They also having the 1 time AS number. Let me show you. So this is also going to be 1 time AS number. See, this AS is going to prepend for the every router. So what is happening? So these routers are getting advertised the route from here also to this router, here also to this router. But once you did the BGP to Ospf advertisement, right? This is going to remove the BGP attribute criteria. This is normal Ospf route. So now they are the Ospf neighbor, and if I am checking the Ospf route, okay, you see here. So R9, show IP route for the 1.1.1. You see, this is learning by the OSPF and the metric is 1. So OSPF is going to use the cost, and that based on the cost, they are going to select the your route. So if I just check here, show IP route, so they are the E2 route. By default, they have the same metric, that is 1. Okay, default. And these are the E2 route, so they have the default metric 20 as well. So even they are not doing any manipulation in the OSPF level as well. So my packet is coming and they are hitting to this router. Okay, this router having the hsrp as an active and sub primary. So this router will check the routing table. It will check the 1.1 from where I am learning right now. So this is going to show you I am learning the route from the router, that is 31.1.1. So this route is going to learn 31. So definitely this is going to redirect the packet for this 31. Okay, because I'm R9. So R10 is going to I'm on the R10. So R10 is going to check something. So R10, if I just check show IP route, so it is going to check I'm learning the route from the 30 routers. So it is going to simply pass at 30, and 30 will check whether I am learning the route which is 1.1 directly from the Ebgp or Ibgp. One route it is also giving. So let me show you. So if I just go in the C1 router and if I check the route, show IP BGP 1 by 1 by 1. So see, there's two routes is coming. One is coming 110. That is your Ebgp route. Okay, this is the one path, and this is the another path, that is the Ibgp. It's the Ebgp, and this is the Ibgp. See, this is from this neighbor. So it is going to check this route, have to take a decision based on the attribute. I am receiving one route from the two neighbors, one directly from here and one directly from the here. This is the Ebgp and this is the Ibgp. So which one I select in my routing table? So this is also come in the path selection method. You can see here, this is the one method, Ebgp versus Ibgp route. So always the route which are going to come from the Ebgp is going to select in the first in the routing table. And this is the region you can see. This is your Ebgp route that is coming, and this is the external and best. External means the Ebgp and best means is installed in the routing table. Internal is the valid but non-best route. So BGP table is saying these two routes I am receiving, but based on the BGP attribute I am just installing my routing table the one route which having the Ebgp preference. So show IP route, if you check that is showing this route is coming from the 112. But if I make this shut this IP address, let me show you. This is going to install the another route. Let me show you again. So if I just go here config T and I'll simply shut this interface. Which interface it is? Let me 0 by 2. Okay, interface gig 0 by 2. I'll shut. So my BGP is going to be down. Then it will see the BGP is down, and then I'll check the routing. See, one has been installed from the 30, and if I check the BGP table, there is only one path, and this is the internal path, and it's become the best now. It's installed in the routing table. You'll see after some it is going to be installed in the routing table. So let me show you again. So 1.1 route, you can see this is learning via the LAN, and it is just not this one. This is okay. Due to redistribution, it's start learning via the Ospf instead of the BGP, because again see there is a metric. Okay, so we have the three type of route. One is running from the Ebgp, which AD value is 20. We are learning the Ibgp, which AD value is 200. We are learning the Ospf, which also having the AD value 10. So now still we are running the Ibgp route, but this Ospf route is getting installed because the AD value is getting more preference. So we disable this one, but still this route is available in the BGP table, but it is not installing the routing table because the same route I am advertising via the Ospf, because I distributed entire networks. That's why it is start reaching here. So this is the reason they are selecting the Ospf as a best route for the 1.1 instead of the BGP route. Okay, so we'll do the filtering also in the future, and we'll make sure how it is going to be, like to stop the Ospf advertisement. So not probably today, I'll cover in the next session. So let me go and no shut first the interface. So this is my G0/2 no shut. So probably after this the BGP is going to be restored. So now we understand the whole scenario. So the route is coming from the LAN. This route is going here, right? Here, and this have to take a decision, either I am the Ibgp or Ebgp. Ebgp is going to take a preference. Now just think about if I am trying to do the manipulation based on the Ospf here, because I have the Ospf network here. So if I am running the Ospf in LAN and I want to force the traffic Ospf route from this, like CE01 to CE02, I have to do some kind of the Ospf level manipulation first. Then it is only going to take this path as a best path. But let me first do the manipulation. Okay. So AS path based manipulation, then we'll do the LAN based manipulation. So AS path manipulation, I want to make sure, as of now you can see C1 route. Let me show you. Show IP BGP. They have show IP BGP. They have the default AS distance, that is this AS path, and one I am learning from this and one I am learning from this. All right. So what I am going to do that instead, see this Ibgp route versus Ebgp, they will going to come in later, but before we have the AS path prepend. So what I am going to do that based on my current topology, I am going to make sure this C1 which is receiving this route 1.1 or this all 4.4, they will get the higher AS number in CE1, and this is going to get the lower AS number CE2. So IP BGP, this is the output before I am doing any configuration. So let me do that. So I'll go in the BGP configuration of the P router, because I want to do these all things from the, and I'll confirm here. This is my P router. Okay. So route map AS path prepend commit 10. Okay, so I have to match IP address prefix list, LAN subnet, right? Okay, and set AS path prepend, and I'll use the AS path that is going to prepend is 6455. Okay, 6455, one time 64, 3 times or 4 times I can do that. Same as 6455 6455. Okay, so this is done. Now I have to configure one of the prefix list, and in that prefix list I have to configure the multiple subnets. So IP prefix list, the prefix list name is the LAN subnet. If you don't know what is the prefix list, then I have to explain. Commit 1.1.1/32. Okay, I have to another subnet 2.2.2, and also I have to put 4.4.4. again also I have to put 8.8. these all 4 subnets. So what I have done, understand, so I created one of the prefix list and do show run section route map. So in this prefix list, what I have done, I created one of the route map. In this route map, I call the prefix list. After calling the prefix list, I just set the AS path prepend, but I have to apply this in the neighbor. That neighbor, from there I want to advertise these prefixes with the higher AS prepend. So what I want when this C receive these prefixes have the AS path prepend. and they should not, right? So on this neighbor, I do not have to apply anything, but this neighbor, I have to configure the AS path prepend configuration in the out direction. Means when I advertise the prefix, I have to make sure these prefix have the higher AS path prepend. So let me do that. How it is going to be happen? So simply we have the outputs here. You see guys here, these are the outputs, but we'll see after this configuration how it is going to look like. So I'm going on this router, P router, and this neighbor 79 neighbor. Okay, so let me go here and do show run section BGP and router BGP. We have 6455. I have to use the neighbor. What is neighbor? 79 neighbor. And route map. What is the route map? This is my AS path prepend route map. And which direction? It's in or out. So I'm sending the prefix should be out. Okay, done. It is done. And if you want to do some soft reset of the BGP, so there is a command clear IP BGP star shop. Just going to reset the BGP neighbor softly. It is going to advertise the route. So now we have done this configuration entirely in the BGP neighbor. We apply the AS path prepend in the BGP neighbor. You want to see the show run section BGP new configuration. It is going to look like in this way. And this is my route map configuration you want to see. So this is going to look like in this way. And we have to check. Now coming to this R C1 and C2, how they are receiving the route. So C1, if I go and check, this was the old and this is the new. Still there is no prepend happen. Probably it will take time. Wait for a while. It must be going to happen. Show IP BGP 1.1.1. Let me check. This is inaccessible. That's okay. There is no problem. But what is the prepend? Let me clear the BGP. Clear IP BGP. Right. I'm doing the hard reset for time being. Just clearing the BGP. So let me. So you see here, they are learning the route from this neighbor. So IP BGP. Okay, let me see one by one. Okay, so let me check first P2 and P4 how they are receiving the route. Let me check on the P. This should receive the P2 first. Okay, so let me verify on the P2. First we have to check on the P2, then we have to check another router. Show IP BGP. So show IP BGP 1.1.32 localist. Okay, I understand why it is happening. Okay, so this is my P2 router and this is the IBGP router, and once it is going to advertise the IBGP to EBGP. Let me check here as well. I should not make any mistake. Show route map. Let me set AS path prepend. Show IP prefix list. Okay, let me check one more minute. Let me apply the same, should work. So show run So run section route map. Let me check why it is not working. Should work definitely, but I just want to verify one more thing. Let me copy this. Let me go here and let me modify show run section prefix. So okay, so I just want to copy this all prefixes as well. Okay, so let me go on this particular PE4. I just want to quickly check one thing. So PE4 show run section BGP and show IP BGP neighbor, which is the neighbor which is receiving this route 7 P, not P4, we have to go to P2. So IP BGP neighbor. All right, summary. So IP BGP summary, and then show IP BGP neighbor. We just have to check this neighbor routes. Let me verify what routes I'm receiving. Okay, so this route I'm receiving, and so IP BGP, the route have the same AS, right? There is no other AS there because they are the IBGP. Okay, so what I'm going to do that simply I make this all configuration here. Should be this configuration copy. So let me copy, let me paste. I want to test one thing, just I want to make sure everything is in place. P2 router, I'll go here, I'll make the configuration here, done, and after that I'll just go do show run section BGP and I'll apply this to eBGP neighbor as well. So I just want to make sure this is not a configuration issue, some concept issue is there, then I'll explain again. So what is the neighbor? Neighbor is my 1110. So route map, right, and I have to use the route map is AS path prepend, and I have to use out. Okay, clear IP BGP asterisk and right. Let me see here. So show IP BGP summary, it is done, and let me check on the C1 router as well, and this time okay. So now we have the AS prepend as well, you can see here. So what is the concept? I have to take one more concept, I have to tell one more concept here. So you can see here, now you can start seeing the BGP prepend list here. So one thing you have to make sure, make sure, right, because we are doing the eBGP between these two providers, and this is my internal IBGP. So if by default you are doing the IBGP prepend here, it is not going to carry to the eBGP neighbor, right? So you have to, right now it is happening and we just tested. So we just have to make sure whatever the eBGP neighbor, from there we have to use the prepend. Then it is going to send the another AS, because they are going to the same AS. So why they are going to do prepend? Because they are going to belong to the same IBGP. So I was doing the wrong thing because mistaken I just configure it. Then I realized no, it is not going to work. That's why I configure here. So now this route are advertising from the P2 with the higher AS prepend. So now C2 start receiving route 5 times AS prepend from this neighbor, and from this neighbor you see how much it is receiving that. Let me show that. So it is receiving the 5 times AS, but it is receiving the 1 time AS, but still this route is valid. Why it is valid? Because of the, like, this route is not a valid route. because again Ospf is there which have the higher AD value, lower AD value. And if I just check here, so IP BGP, you can see this path which is like getting this route from this neighbor. This is the inaccessible right now because they are receiving the path, but they don't know how to reach from that to this particular router. So if I want to use that, what I can do simply, I have to advertise this path in the OSPF as well, or I simply advertise this network in the OSPF, then it is going to be accessible. So let me do that. So this is inaccessible, means the next hop is not reachable. That's why this route is not getting installed in the routing table as per the my BGP behavior. So let me go in the which router, the CE2, and I just do some quick modification in the OSPF. Show run section OSPF. And I'll simply go router OSPF 10 and I configure the network 210.0.0.0.0.0.0 like 3, or area I'll just put the 0. So now it is advertise the route. So this route must be now reachable to this particular routing table as well. Show IP route pipe include 210. Let me show you. See, this route has been there. Now again check this. So this is accessible now. You know how to reach this particular destination. So if I just go and check again, see, this one become the best. Why? This one is still non-best. So this is what I want to show you. So BGP, and if you see here, this route you are getting here, it is a non-best route. This is the best route here because they have the lower AS path, which is the higher AS path. So based on this attribute criteria, right? Based on this attribute criteria, if your weight is going to be checked, your local frequency is going to be checked, your origin, the AS path is going to be play a vital role still, because this router is getting a 2 copy of route. Understand? One from here, but this having the 4 time or 5 time AS prepend here. This is getting from here, but this is learning from the Ibgp event. You can see this route is learning from the Ibgp, but still they are having a lower AS path prepend. So you see here, this is your, let me show here. So IP BGP 1.1.1/32. This route is internal, this is the external, this is the Ibgp route, which AD is 200. This is the interview question, guys. This AD is 200, this AD is 20, but still it is not installing in the routing table because the first criteria is AS path prepend. See this, the attribute list. The first criteria is AS path prepend, then 7th position we have the eBGP versus Ibgp route. So always the AS path prepend is going to check first. If it is going to match, then it is never going to check the AD values. That's the reason it is installing the route. So now this is the route. Now if I initiate the traffic, understand, earlier we checked that this was taking this part. Now let's check how it is going to out the traffic. This was the old trace. Now let me trace the new one again. Now you can see the first path, you see the result. First path, your packet is in the gateway. This is your gateway and this is your R10 router. The first path is R10. Let me draw in this way. This is the PC A, then your R10, and this is the 3 router. This is the R9. The packet has been moved. The packet has been moved from this one to this one. Let me show you. R9 having this IP address. .3. Show IP interface brief. So you will see .3 is the R9 IP address. So now your packet has been moved there. R9, let me go in the trace. So user R9 and then R931. 31 is a CE2 router. So it is going on the CE2 router and then it is going to P4 and then it is going to the PDC. This is the new path. because we did the manipulation. This was the old trace, just 4 hops. Now you can see the 5 hops because of the path manipulation with the AS path. So we just force the communication. My traffic earlier it was going to this path, but I just want no, this should go at this path. So I just force the communication. First it is hitting to the gateway, then it is landing to this actual data path, and then it is going to here again, and then it is going to this way. So this is my new path of the routing. So I hope you guys understand how all the manipulation is happen and what is the best way to understand for the AS path prepend manipulation and Ebgp versus Ibgp route selection criteria. Still we have to understand the weight. Still we have to understand the origin. We have to understand the oldest route. And these all attributes we have to understand. MAD we have to understand. But I believe for time being you understand how this AS path event has been done and how the Ebgp versus Ibgp concept was done and how the redistribution was done. So I hope this session is useful. If you really like, just put your comments. If you want to share some your feedbacks, that's the most welcome as well. You can share some your feedback, some suggestions. That is really going to be appreciated. Just for the learning, so you can, this is just for the learning, so you can just upgrade yourself, right? And you understand a little bit more about the BGP. And this is a real base scenario what I explained, so you should know step by step how it is going to be built a network. But definitely in the next session all attribute is going to be covered. Definitely I'll take 2-hour session more, and the all attribute is going to be covered for the path manipulation, and then we take the another 2-hour session. On that 2-hour session we are going to do the deep dive advanced, like the community, how it is going to happen, right? How the prefix list and access list is going to be configuration, how the MP BGP is going to be configured. So that all things we cover latest test. So thank you guys, have a great day further, take care, bye bye.